Hello, today we're going to talk about statistical hypothesis. So, the population mean is denoted by the Greek letter mu. We can make a claim that the value of this mean is a specific value, as meaning a number, which we're going to call as mu sub 0 or mu naught. Therefore, because we make a claim that the mean is a specific value, we can say that mu is equal to mu sub 0. This is what we call our null hypothesis. Okay? And our null hypothesis is normally denoted by the letters H sub 0. All right. The null hypothesis will be accepted as true unless we find or can provide sufficient evidence to reject it. The null hypothesis means that there is no difference between mu and mu sub 0, meaning that they are the same, they are equal. If our null hypothesis, H sub 0, is rejected, we are going to accept that there is a difference between mu and mu sub 0, and this statement will be called the alternative hypothesis. So there are three types of alternative hypotheses. You have one-tailed and you have two-tailed. So an alternative hypothesis could be one of the following. So we can have that mu is less than mu sub 0. This is a one-tailed alternative hypothesis because we're only focusing on the values that are less than. We can also have that mu is greater than mu sub 0, which is also one-tailed because once again, we're only focusing on greater than. And then our third alternative hypothesis is that mu is not equal to mu sub 0, and this will be considered a two-tailed hypothesis because we don't care whether it's greater than or less than, we just know that it cannot be equal to. So we're focusing on both sides. So let's look at some examples. It says, state the null and alternative hypothesis for each scenario. So number one, it says, a researcher thinks that if an expectant mother uses vitamins, the birth weight of the babies will increase. Okay. The average birth weight of the population is 8.6 pounds. So our null hypothesis, or H sub 0, is going to be that our average is going to be equal to 8.6. Okay, because we're saying that those values are the same, they're equal to each other. On the contrary, our alternative hypothesis, and we can go back up here, our alternative hypothesis is denoted by H sub 1. Okay, so we can say here that H sub 1 is our alternative, and it says that the birth weight of the babies will increase. So this is saying that the average birth rate is going to be greater than 8.6. So that's our null and our alternative. Number two, it says an engineer hypothesizes that the mean number of defects can be decreased in the manufacturing process of compact discs by using robots instead of humans for certain tasks. The mean number of defective discs per 1,000 is 18. So I'm going to say that my null hypothesis is that my mean or my average is going to be equal to 18, that they're the same. On the contrary, my alternative hypothesis, it says that the mean number of defects can be decreased or be less than. Okay, so I would say my alternative is that mu is going to be less than 18 here. All right. Last but not least, example 3, it says a psychologist feels that playing soft music during the test will change the results of the test. In the past, the mean scores was 73. So I know that my H sub 0 here is basically saying that my mean is going to be equal to 73. However, for my alternative hypothesis, it says that they feel that playing soft music during the test will change the results of the test, meaning it may not change it in a negative or a positive way. It's just going to change. It's going to be different. So here I can say that my mu or my mean is not going to be equal to 73. So now let's look at the student's t-test. So now that we know how to write our null and alternative hypothesis, we are going to learn how to conduct a t-test to determine or compare our two means. So there are 6 steps to success for this. The first step is that you want to state your null and alternative hypothesis, and then you want to identify or choose your significance level, which we denote as the letter alpha, and that's a Greek symbol. Then you want to calculate or identify your test statistic, which we call T, for your data. Now, the equation for your test statistic is equal to the mean of the sample, which is X bar, subtract the mean of your population, which is M sub 0, divided by the sample standard deviation, divided by the square root of the sample size. So once we calculate our test statistic, and I am going to show you how to do it in the calculator as well as by hand, so don't worry. You can go to step 4, which you have to use your calculator to find the p-value, p, and then we are going to either reject or accept the null hypothesis. You are going to reject the null hypothesis if your p-value is less than a significance level, and you are going to accept the null hypothesis if your p-value is greater than the significance level. Once we do that, we are then going to state the conclusion and interpret it in the context of the problem. So example 1, we're going to go over how to conduct a t-test using statistics that are already calculated. So it says, in an athletics club, the mean 400-meter times of all of the members are known to be normally distributed with a mean of 62.5 seconds. Okay. The club employs a new coach. After a few months, they take the sample of the 400-meter times of 20 randomly selected club members, and it says that the mean of the sample was 63.8 seconds, and the estimate of the population variance was 7.84. Is there sufficient evidence at the 5% significance level that the mean 400-meter time has changed? So the first thing that we want to do is we want to state the null and alternative hypothesis. So the null hypothesis is that my mean times will be the same. So that means that my mu will be equal to mu sub 0. And remember, mu sub 0 is the population mean. It tells you in the very beginning that the mean 400-meter times of all of the members, that means the total population, are known to be normally distributed with a mean of 62.5 seconds. So I know that my null hypothesis is that my mean, or my mu, is equal to 62.5. We also know that in order to find our alternative hypothesis, it's saying that we want to know if the mean 400-meter time has changed. I don't care whether it has changed to be less than or greater than. I just know that it is different. So that means that my alternative hypothesis is that my mean will not be equal to 62.5. So this is a two-tailed t-test here. So once we do that, we can then look at our significance level. It has already told us that it wants us to look at the 5% significance level. So here we know that our alpha is equal to 5%, which is which is equal to, not approximate, 0.05. So that is our significance level here. Next, we want to calculate or identify the test statistic. So in order to find the test statistic, I'm going to show you how to do it by hand using the formula. So we have T is equal to X bar, which is the mean of the sample. The mean of the sample, it says in the problem, was 63.8 seconds. So that's going to be 63.8, subtract the mean of the population, which we know is 62.5. And we're going to divide by the standard deviation from the sample. And we already see that the standard deviation, we see that they didn't give it to us. They gave us instead the variance. So they're saying that the variance is 7.84, and we know that the variance is the standard deviation squared. So if the variance is 7.84, then I know that my standard deviation is going to be the square root of that. So if we take the square root of 7.84, we will end up getting 2.8. So I know my standard deviation is 2.8 here. So we're going to have 2.8 divided by the square root of my sample size. My sample size is 20 because they said they had 20 randomly selected club members as a sample. So now that I have that, I'm going to type this into the calculator exactly how it looks. And then once I do that, I will be able to tell what my test statistic is. So my test statistic is approximately 2.08 in 3 sig fig. All right. So now we need to calculate the p-value for part D. So in order to calculate the p-value, I'm going to go ahead and I'm going to run the test. So I'm going to go to stat, go over to test. I'm then going to go down to t-test. And then you have an option whether you want to input or conduct your test from a list of data or from the statistics. We do not have a list of data here. So we're going to scroll over to statistics and hit enter. And then we're going to input our information. So we know that mu sub 0 is going to be our population mean, which is 62.5. We know that our x bar, which is our sample mean, we are going to have that as 63.8. And then we have SX, which stands for the standard deviation. So before we move on, I want to make sure I clarify something so there won't be any confusion. So when we learned how to calculate our one variable statistics in the TI-84, we know that there is actually two versions of the standard deviation when we calculate our one variable statistics. We have SX and we have sigma X. SX refers to the sample, whereas sigma X refers to the population. Okay. If we look at example number 1, it says that the population variance was 7.84. We know that the standard deviation is the square root of the variance. So when we took the square root of 7.84, we got that the standard deviation was 2.8. We have to understand that, yes, the 2.8 is technically the population standard deviation. And we know that in the formula to find our test statistic, we need the sample standard deviation. However, the only standard deviation that we have to use here is the 2.8, which is the population standard deviation. So we are going to accept the 2.8 as our sample standard deviation because we have no list of data to actually calculate the statistics from to actually find out what the actual sample standard deviation is. So we are going to use the 2.8 as the default standard deviation in this case. So when we do that, we are going to end up putting 2.8 here. And then we are going to find our number of our sample size, which is 20 runners. And then we know that our alternative hypothesis is that mu is not equal to mu sub 0. And then we just go down to calculate and we press enter. And as we can see here, our test statistic still is about 2.08. So we have confirmed that. And now we can see that our p-value is approximately 0.0517. So now for part E, it says conduct the t-test to determine if the mean time has changed. So I know that my p-value is greater than my significance level because I know that 0.0517 is greater than 0.05. So from this information, we can actually conclude that there is significant evidence to accept the null hypothesis. In other words, we are not going to reject it, okay? And from there, we can conclude the mean time is not different, meaning that the mean time is still around 62.5 seconds. All right, so now let's look at example number 2, how to perform a t-test when you have raw data sets. So it says, Kaylee is investigating whether the average rainfall last year was higher than in the past. She knows that the average monthly rainfall in May over the past 70 years was 51 millimeters. She collected the rainfall data for May of last year for 8 different locations, obtaining the following results. So it says here that she is going to conduct the t-test using a 10% significance level, and we want to state the conclusion for the test. So as we can see here, we have our 8 different locations and we have their corresponding rainfalls. So the first thing that we want to do in part A is we want to state the null and the alternative hypothesis. So we know that the null hypothesis is that nothing has changed. So we're going to say that H sub 0 is that mu is equal to 51, because we're going to say that it's going to be equal to our population mean. So now our alternative hypothesis, H sub 1, is going to end up being that our mean, and she said that she is investigating whether the average rainfall last year was higher than in the past. So we're going to say that our alternative hypothesis is that mu is greater than 51 or higher than 51. So the next thing we need to do in part B is we need to identify the significance level, and we see that here we're going to use 10%. So we know that our alpha is 10%, which is equal to 0.1 or 0.10. So the next thing that we need to do is calculate our test statistic. Well, the one thing that you need to know when we calculate the test statistic, we know that we're going to have that T is equal to your mean of the sample, X bar. So the mean of my sample, we don't actually know it because we were not given the statistics. We have the raw data. So in order to find the mean of the sample, we are going to have to go to stat, edit, and we're going to have to type in our measurements for the rainfall. There is no need for me to type in the location numbers. We just know that there are 8 locations, so that means I'm going to have 8 measurements. So I'm going to have 52, 71, 45, 83, 61, 65, 73, and then we're going to have 48. All right, so these are my rainfalls. So if I want to find the mean here of these rainfalls, I'm going to go to stat, edit, one variable statistics, and then I'm going to go down to calculate. So I see that my sample mean is going to be 62.25, and we're going to subtract our population mean, which is 51, and then we're going to divide it by the sample standard deviation. So now, as you can see here, we're going to use the SX because we can find it. Remember, in the last example, we used the sigma X because we didn't have a sample standard deviation. So it was like our default. We had no choice but to use it. So now that we have our sample standard deviation, that is going to be about 13.3 in 3 significant figures. So it's going to be 13.3 divided by the square root of our sample size, which is 8, because we have 8 locations. So now that we have that, we can just type this into the calculator exactly how we have it. So we're going to have alpha y equals 62.25 minus 51 divided by 13.3 over the square root of 8. So now that we have that, we see that our test statistic is approximately 2.39 here. So now we can calculate our p-value by running the test. So we're going to press stat, we're going to go over to test, and then we're going to go to t-test. Now I'm going to show you how to run this t-test using the data and using the statistics. So we're going to do the statistics first because we've already done that. So as you can see here, when we press stats, if you look here, it says mu sub 0. We already know that our mu sub 0 is our population mean. So that should be 51 here. Our sample mean, X bar, is 62.25. And our standard deviation is this 13.29, whatever. So you can leave that in like a long number like that, or if you wanted to use 13.3, you could. It really doesn't matter. Your answer will still come out approximately the same, and I will show you in a minute. So next, we're going to go down to and change our alternative hypothesis to greater than mu0. And then we're going to go to calculate. So when we go to calculate, as you can see here, my test statistic, is approximately 2.39 in 3 sig fig. And we have our p-value. And our p-value here is approximately 0.024 in 3 sig fig, because that 7 is going to make that 9 go up to a 10, which is going to make the 3 go up to a 4. All right. So if I go back to stat and then go to test, if I wanted to use 13.3 as my standard deviation, you still would have seen that you still get approximately the same information. So the test statistic is still 2.39. And as you can see, my p-value still rounds out the 3 significant figures to 0.024. Okay, so nothing really changes whether you decide to use the 3 sig fig version of the standard deviation or the full version of the standard deviation. So now I'm going to show you, we're going to go back to test and t-test, and then I'm going to show you how to press enter on data, and you want to then calculate this information. So we already know that our mu sub 0 is 51, that's our population mean, and we know that our list of data is coming from L1. We know that our alternative hypothesis is greater than mu0. The frequency is going to stay 1 because remember, the frequency normally comes from L2, but we don't have anything in L2. So then we go to calculate here, and as you can see, we get the same value for the test statistic t and the same p-value. So there is really no difference in how you do this. All right, so either way, you could have calculated your statistics by running the one variable statistics and typing in the data, or you could just use is typing in the statistics, or you could have just used the data portion and then you could have put everything in there from L1 and then put in your population mean. Same answer, 2 different ways. So now we want to conduct the t-test to determine if the average rainfall last year was higher than the past. So we have to look at the p-value. So here we can see that p is going to be less than the significance level, okay? And that is because 0.024 is less than 0.10, okay? So from this, we can conclude that there is enough or sufficient evidence to reject the null hypothesis. Because remember, when your p-value is less than your alpha level or your significance level, we reject the null hypothesis. So now we should be able to say the average rainfall is higher than in the past. So if you have any questions on students' t-test, please let me know, and I will be more than happy to assist you. Have a great day.